Start. Yeah. Joerg Mueller, you're head of urban air mobility at Airbus. Is this today the official launch of CityAirbus next generation, the commercial launch?
Yes, it's indeed the project launch for such a vehicle. A commercial launch would be that we're starting selling it. Yeah? We are not yet there. This is the launch of the development of a product of our next generation vehicle. And as I said, yeah, we're going about it step by step. We fly a first prototype in 2023, and we aim for certification starting in 2025, and then an entry into market thereafter.
Can you describe the characteristics of your UAM?
Yeah, with pleasure. So actually what we're targeting a vehicle that is flying in and around urban areas with an adapted performance and actually optimized for, on one side, simplicity. So we want to have a relatively simple vehicle in order to develop and also operate this vehicle efficiently. And on the other hand, we want to have a certain performance on the vehicle so that it can really serve markets, serious markets where there's a strong value to the passengers. Yeah. So in order to achieve that, we think a vehicle needs about an 80-kilometer range. This is sufficient for about 95% of the cases that we were looking at, and will already benefit to the travelers in and around urban spaces. It will fly at about 120 kilometers an hour, so that's a speed that still allows a relatively simple design on one side, but on the other side actually provides already a forward flight performance and a time gain that is significant, especially if you compare it to ground transport options where you often are at below 10 kilometers an hour or something like that when you're in a traffic jam or during rush hour. So yes, a clear benefit due to that. We obviously have to... we have the noise background. So that's more than 60 decibel. No, so we need to be very silent. That's what I wanted to say actually. So the noise level is very, very important because you want to operate close to where people
and
live
that's something
work.
That you need to fine-tune.
That's something we need to work. We have done a lot of work on that. We have done wind tunnel testing, bench testing. We've overflown urban areas. We've measured the noise propagation on facades, on buildings. We have measured what kind of noise characteristics get down to the ear of somebody on the ground. All these kind of elements allow us actually to improve the noise signature of such a vehicle. Mm-hmm. And on top of that, I would also use all the experience we have obviously gained from the Vahana and the CityAirbus vehicles that show us how noise is actually radiating, in which direction, and how to shield it, and how to put the propeller so that we minimize the effect.
But you must also have looked at your competitors. There is a big market out there, many projects. Not all will probably become reality. Mm-hmm. But if you look at the main competitors that are now all going commercial, what are you doing differently on CityAirbus?
So, the first part of your question, so yes, there is clearly a lot of competitors out there, and they are kind of developing different kind of solutions. They are targeting slightly different market segments, but they are using different types of technologies as well. And I think that's the wealth of this currently boiling urban air mobility environment. We are actually witnessing how a new standard form for flight, for vertical takeoff and landing flight on these kind of shorter distances emerges, and all this innovation potential that we have in startups, incumbents, ourselves, all this will actually mature the industry and mature the technology so that we at a certain time have something that's kind of converged to a real ideal solution, like an airplane converged to what we have today, or a helicopter looks like that today.
But the design of your CityAirbus, is that on where, what is the biggest difference with your competitors?
Yes, so what we have chosen is a design that is relatively simple. So no moving surfaces, no tilting parts, to make the whole aeromechanical configuration simpler, more manageable, and also during transition flight, etc. There's no change of aerodynamics mainly on one side, but still using kind of that simplicity combined with the wing that brings us a performance that's significant. And I think that is the right compromise. But again, this is an uncertain market that's evolving, so we'll learn a lot as we go. Perhaps the future product will look different, you never know that, but this is what we think is the right thing at this point in time.
One of the main debates over here at the Airbus Summit is the social acceptance of UAMs. I know many people who don't like aircraft flying over their houses. Having a UAM over your house or in the urban area will cause disturbance. How do you think the people will respond in the near future?
Yeah, first of all, you need to imagine such a vehicle overflying an urban area is very silent. So it's when there's really kind of a lot of let's say activity in the city, it's basically inaudible. It's relatively silent, and you can witness that today if you look at modern small airplanes, general aviation airplanes that fly at a certain altitude and with a certain flight profile on certain routes. They are very difficult to hear already today, and this is with combustion engines. Yeah? Now we are going into electric engines, so it will be even better. However, you will never completely avoid it. You will see it, so visually you will perhaps feel yourself disturbed, and necessarily, I mean, it will use space on the ground where there's infrastructure needed for takeoff and landing. All these aspects obviously need to be dealt with.
But can they be overcome?
They can be overcome. I mean, we believe that they can be overcome. Otherwise, I think we wouldn't do it.
And the safety issue, you are preparing maybe even an autonomous UAM?
Yes, absolutely. So the safety issue, clearly, we have the regulations in place. EASA has developed this special condition VTOL with the highest safety levels that they have prescribed, and we are complying with these safety levels. Yeah. So these certification standards are already a great basis for a safe operation thereafter. And the second part of your question was
the safety of operations, autonomous flying.
Autonomous flight, yes, sorry.
How far is that away, you think?
Well, on that one it's difficult to give a timeline because it's not fully under our control. You know, the technology needs to become available, and it's not trivial to have all the function of an airplane, all the operational steps, the concept of operations fully automated, fully autonomous, within kind of the brain of such an aircraft. So technology-wise, it needs to be done, and then you need to prove that this is safe, and sustainable, by the way. So that this becomes safe, and then you need to be able to certify it and have the right certification based on it. And all that comes with a question around public acceptance. So would somebody, in this case, from a passenger point of view, would somebody climb on board such an aircraft if there's no passenger on it? So this will probably take a bit of time as well before people are used to such an idea, but it will most certainly come. And when all this comes together, then we can say, okay, now we really have fully autonomous operations, fully autonomous commercial passenger transport services, right? And that's still a few years out.
That's more towards 2030 probably.
Yeah, or beyond.
Or even later,
or even
beyond.
Yes,
okay.
Exactly.
Well, thank you very much.
Yeah, you're welcome.